The topic for the discussion is file organization. A file is organized logically as a sequence of records. These records are mapped onto disk blocks. The database is stored as a collection of files, and each file is a sequence of records. A record is a sequence of fields. An alternative is to structure our files so that we can accommodate multiple length for records. However, files of fixed length records are easier to implement than the files of variable length records. Now we move on to fixed length records. In this approach, we have an example of the given figure. If we assume that each character occupies 1 byte and the data type real occupies 8 bytes, our account record is 40 bytes long. A simple approach is to use the first 40 bytes for first record and the next 40 bytes for second record, and so on. The two problems with this approach is it is difficult to delete a record from this structure. The space occupied by the record to be deleted must be filled with some other record of the file, or we must have a way of marking deleted records so that they can be ignored. Next one, the block size should be multiple of 40, otherwise some records will cross block boundaries. Here the each record of size 40 bytes, that is part of the record, will be stored in one block and remaining part is another. Thus require two block access to read and write such a record. When a record is deleted, we could move the record that came after it into the space formerly occupied by the deleted record, and so on. Such approach requires moving a large number of records. It might be easier simply to move the final record of the file into the space occupied by the deleted record. But it is undesirable to move records to occupy the space freed by a deleted record, since doing so requires additional block access. Thus, we need to introduce an additional structure. At the beginning of the file, we allocate a certain number of bytes as a file header. This header contains a variety of information about the file, and this header will store address of the first record whose contents are deleted. The first record will now store address of the second deleted record. Thus, the deleted records form a linked list. This is shown in figure. First one is a header, and the header will store the first record whose contents are deleted, and the first record will now store the address of the second deleted record. Likewise, it forms a linked list, which is often referred to as the free list. This is called free list. In this figure, the free list after records 1, 4 and 6 have been deleted. On insertion of a new record, we use the record pointer pointed by the header. We change the header pointer to point to the next available record. If no space is available, we add the new record to the end of the file. Insertion and deletion for files of fixed length records are simple to implement because the space made available by a deleted record is exactly the space needed to insert a record. So this is about fixed length records and free lists. The next topic is variable length records. Variable length records in databases arise in database systems in several ways. Storage of multiple record types in a file, record types that allow variable lengths for one or more fields, record types that allow repeating fields. So here we will consider a record. Here we are implementing in two approaches. First one is byte string representation and um, fixed length representation. Now we will see byte string representation. Okay, here in a simple method for implementing the variable length record is to attach a special end of record. Here this is the end of record symbol. Um, this end of record uh, at, at the end of each record we can then store each record as a string of consecutive bytes. In this byte string representation it has some disadvantages. Um, it is not easy to reuse space occupied formerly by a deleted record. There is no space for records to grow longer. If a variable length record becomes longer, it must be moved. So there is no space if a record can grow longer. The basic byte string representation is described here, used for implementing variable length records. This modified form of byte string representation is called a slotted page structure. It is commonly used for organizing records within a single block. This figure shows the slotted page structure. As shown in a figure, there is a block header at the beginning of each block containing the information like the number of record entries, end of free space in the block, an array whose entries contains the location size of each record. The actual records are allotted contiguously. The records are allotted contiguously one after the other, starting from end of the block. Um, the free space in the block is also contiguous between the final entry of the block and the final entry in the header array and the between the header of the array and the first record. If a record is inserted, space is allocated for it at the end of the free space containing its size and location is added to the record. If a record is deleted, the space that it occupies is freed and its entry is set to deleted. Further, the records in the block before the deleted record are moved so that the free space created by the deletion gets occupied. So this is about slotted page structure. And the next variable length record representation is fixed length representation. It is another way to implement the variable length records efficiently in a file system. Is to use fixed length records to represent one variable length record. There are two ways of doing this. One is reserved space and list representation, also called as pointer representation. In this reserved space, if there is a maximum record length that is never exceeded, We can use fixed length records of that length. Unused space is filled with a special null or end of character symbol that is shown in figure. The reserved space method is useful when most records have a length close to the maximum. Otherwise, a significant amount of space may be wasted. The next one is a list representation or pointer representation. We can represent variable length record by a list of fixed length records chained together by pointer. To represent the file by the linked list method, we add a pointer field. Um, this is the figure of pointer method. Um, the disadvantage of the structure is um, we waste space in all records except the first in a chain. The first record needs to have a branch name. This is the branch name field. This is account number and it is a balance. This is the record numbers. The first record needs to have a branch name value, but subsequent records do not. The first record um, have a branch name, but the other records do not have a branch name. To deal with this problem, two kind of blocks are introduced in our file. One is anchor block and overflow block. An anchor block which contains the first record of a chain, and the overflow block which contains the records uh, other than those that are in the first record of a chain. So this is all in an anchor block, and overflow block contains this. Thus all records within a block have the same length, even though not all records in the file have the same length. This is all about fixed length representation, and we have seen two implementation in fixed length representation. One is byte string representation and fixed length representation. Thank you.